This video is going to talk about how to solve trigonometric equations, and this is really just the basic intro to solving trig equations. It's actually really a reminder for pre-calc level students of something that we've sort of done before. So again, just a quick reminder of how to use an inverse to solve an equation. Now, sometimes we don't really need the inverse. Over here at the left, you might recognize the cosine of x equals root 2 over 2. Well, that makes me think on my unit circle, root 2 over 2 always reminds me of 45-degree angles. 45-degree angles. And the cosine would be equal to a positive root 2 over 2. Remember, cosine is adjacent over hypotenuse. So that means that our adjacent needs to be a positive value because our hypotenuse is always positive. So again, the cosine would be a positive root 2 over 2 in quadrants 1 and 4. And therefore, our two answers, without really doing a lot of work, would be 45 degrees or 360 minus 45, basically 315 degrees. Now, be careful though, because notice up in the directions, we're asked for x to be a value between 0 and 2 pi, which means I don't want degree answers. We need to remember that 45 degrees is really pi over 4. And again, down in quadrant 4, a full 2 pi would be 8 pi over 4, minus one of those would be a 7 pi over 4. Both of those values still less than 2 pi, but again, greater than 0. So again, you don't necessarily have to use anything fancy if you know your sort of special triangles as we go. However, over here at the right, the tangent of x equal to 0.532. Now that's not a special triangle side length. So there, what we're going to want to do is go ahead and take our inverse tangent of our ratio. Remember that the x is our angle, but inverses find angles. Inverses will find us that x value, that angle value, when we take the inverse of the ratio of sides. So in that case, let's go ahead and hop onto our calculator. We're going to take the inverse tangent. So second tangent. And notice up here, I'm already in radian mode, so we're in good shape there. But the inverse tangent of 0.532, and we'll hit enter, is a 0.489 approximately. Right? X equals 0.489 radians, which would be, again, 2 pi being 6.28 approximately. 0.489 definitely less than that value. So again, that's one good answer. However, from 0 to 2 pi, you may remember the tangent can be positive in quadrant 1, which is where our 0.482 or 489, angle came from. But it can also be positive down in quadrant 3, which means I need to take my reference angle, 0.489, and I need to add that on to a full pi units. So my other answer basically will come from taking 0.489 and adding pi units onto that. 3.631 should also be a perfectly good angle measure. Definitely between 0 and 2 pi. And I definitely know that's greater than pi. It's down in quadrant 3. Again, those are good answers. And again, you can always double check them. The beauty of solving equations, we can always go back to our calculator and say, what is the tangent of that number? And you'll notice that it will come out very close. We used a rounded value here, right? The calculator rounded off to the nearest 9th decimal place. So again, we were fairly accurate out to almost 9 or 10 decimal places there. But notice we got 0.532 back as an answer. Don't forget that from 0 to 2 pi, most trig values, most trig ratios will happen twice. So it's a question of which quadrants do we want to be in. Remember that tangent's positive in 1 and 3, negative in 2 and 4. Cosine's positive in 1 and 4, negative in 2 and 3. And the sine would be positive up top, right? Sine's kind of like the y value on a unit circle. So again, sine's positive in 1 and 2, negative in 3 and 4. Take advantage of that when you're looking for that second angle, and don't forget to check your answer. It's always a good idea to make sure it came out to that positive 0.532 or really close to it. I hope that helps you solving equations, and we'll have some more information for you coming up in a few other videos. Have a great day.